Okay. My hope is that you have the previous day's note guides for section 2.2. Um, we went over, let's see here, horizontal translations, left and right. It's a minus h or a plus h depending on which way you want to go. If you want to go to the right, it's a minus h. You want to go to the left, it's a plus h in the grouping symbol. Vertical, add some value k. You want to go up, it's positive. You want to go down, negative. Reflection in the x-axis. If you want to reflect something in the x-axis, you multiply the whole function, not just the input, but the whole output. Remember, that's what this means, the whole output, negative f of x, negative output, you're going to get a reflection in the x-axis, versus if you just put the negative in front of the input, a reflection in the y-axis. Moving right along. And then horizontal versus vertical. So what you have here on the front, vertical stretches and shrinks. If you take a coefficient A, and you multiply it by the input only, notice it's right in front of x, remember that's your input, then you're going to get a horizontal stretch or shrink. Okay? It'll be a shrink if it's a fraction, look at 1 over a, and it'll be a stretch if a is greater than 1. Okay? Or if a is greater than 0, in other words. Okay? So yeah, on Friday we went over horizontal stretches and shrinks. So if a is greater than 1, that graph is going to get closer to the y-axis, so that's going to be a horizontal shrink. If a is in between 0 and 1, which means it's a fraction, it's going to be a horizontal stretch. Horizontal stretch. Because it's going to get farther away from the y-axis. As opposed to a vertical shrink or stretch, here we multiply the whole function by a value, a. The whole output, in other words. We went over this on Friday. If you were absent on Friday, you're going to watch that video. If a is greater than 0, or if a is greater than 1, rather, we got a vertical stretch. If a is a fraction, remember whenever you see a between 0 and 1, that means it's a fraction. If a is a fraction, you got a vertical shrink. Okay, so now, let's go ahead and look at example 1 at the bottom of your note guide. Actually, you know what? We did 1, 2, and 3 already with previous examples, just not on this paper. So we're going to go to example 4. So right there, just flip the page. We're going to start with example 4 because, again, we did 1, 2, and 3 about a week ago when I introduced this section. So f of x equals 1/2 x plus 8. We want to reflect this in the x-axis. We're going to make a new function, g of x, that reflects f of x in the x-axis. So here we go. So g of x equals, let's take 1/2 x plus 8 and reflect in the x-axis. All right, let's look at our notes to see, how do you reflect something in the x-axis? Let me see here. Is that multiplying the input or the output by something? Let's see. Notice it's multiplying the whole output by a -1. So you want to have your notes organized so you can refer back to how you do a certain transformation. So I'm going to multiply the whole output by a -1 as opposed to simply the input. If I multiply just by the input, that's a reflection in the y-axis. But here I want a reflection in the x-axis. So let's go back over here. So if I'm going to multiply the whole dang output by -1, the whole output, remember, look at 1/2 x plus 8. So I'll take a -1 and multiply it by the whole output. 1/2 x plus 8. I have to multiply the whole output by a -1. You can go, Kasha, to the girl if you want. So let's see, a -1 times 1/2 x is going to be a right here. So when you want to reflect something in the x-axis, you multiply the whole output by -1. If you want something to reflect it in the y-axis, you multiply only the input by -1. Notice. Input versus output. The whole output would be the whole function. Good question. -1 times 1/2 is going to be -1/2 x, plus -1 times 8 is a -8. We're done. Here's g of x. Here's a transformed function. That function will be reflected over the x-axis. Okay. How about number 5? 4 plus absolute value of x plus 1 reflected in the y-axis. Okay, so reflection in the y-axis involves multiplying only the input. Notice. Right, just the input now. Wherever I see x, I'm going to multiply the x by -1. Let's do it. So g of x equals 4 plus absolute value of -1 times x would just become -x plus 1. We're done. That was easy. Let's multiply the input by -1. There's your new function. That would be reflected. That would reflect the original function in the y-axis. Questions so far? All right, let's go on to 6. Vertical shrink by a factor of 1/2. A vertical shrink by a factor of 1/2, or 1/5 rather. Okay, so vertical shrink. So for vertical shrink, do I have to multiply the whole output or just the input by some value of 1/5? Let's see. Let's see, vertical stretches and shrinks. So it's saying multiply the whole output, notice. So here's the whole output. I'm going to multiply it by some factor A. If I want to shrink, look at it, if I want to shrink, it's got to be greater than 0. If I want to stretch vertically toward the x-axis, actually we want to shrink. So notice, multiplying the outputs by A stretches the graph vertically away from the x-axis when A is greater than 1, and shrinks the graph vertically. That means it smashes it towards the x-axis when A is a fraction. And so we're going to multiply the whole function by a value A. So looking at number 6, I'm going to multiply the whole function. So f of x equals, the whole function is -5x. That's your whole f of x. I'm going to multiply that whole thing by a factor of 1/5. Not just the input, but the whole output. Say again? Because that's what makes it shrink vertically. Were you here on Friday? When we multiply the inputs only by a value A, like say, I think I asked everybody their favorite number, Vega's favorite number, and we took those numbers and multiplied them by the inputs only. That was a horizontal stretch or shrink. But then when we multiplied those same numbers by the outputs, that was a vertical stretch or shrink. So we want a vertical, so we're multiplying the whole output, which is -5x, by 1/5. So we're going to have a vertical shrink. Watch this. 1/5 times -5, let's make it into a fraction. So f of x, actually, you know what, it shouldn't be f of x, it should be g of x. Forgive me. Shame on me. G of x is a new function. So g of x is, these cancel out, I just have -1x. There it is. So this would be a vertical shrink of that. All right. Number 7, we want a vertical stretch by a factor of 4. That means I got to multiply the whole function by 4. Because it's a vertical. Vertical stretches and shrinks, the whole function has to be multiplied by that number 4. Now notice how this is a little tricky now. This is the first example where I have a nasty absolute value function. I'm going to multiply the whole function by 4. Watch this. So g of x is going to equal to 4 times, look at this. Look what I'm going to put in parentheses, the whole function. That's going to be x plus 3 absolute value plus 2. The whole function. Because the whole function is the output, remember? The output happens when you take the input and you do all this stuff to it. That's what happens with an output. If I take an input, I have to add 3, take the absolute value, then add 2 to get the output. So the whole output is represented by the whole function. So let's distribute. G of x then is 4 times the absolute value of x plus 3 is going to be 4 absolute value x plus 3 plus 4 times 2 is 8. There it is. Now notice when I multiply 4 times the absolute value of x plus 3, I can't see those absolute value symbols like parentheses and distribute the 4 into the x and then the 4 into the 3. It doesn't work that way. Absolute values are different than parentheses. So don't think you can do this. 4x, you can't do this. That doesn't work. That only works with parentheses, not absolute value symbols. All you do is put that 4 in front of the absolute value and you're done. So be careful there. That's a little mental note you need to take. There's a temptation to take the 4 and do everything inside the absolute value. Don't do that. It's 4 times that whole absolute value. Cool. So this g of x would be stretched by a factor of 4. Oh, you tell me. We still got 8 and 9. Let's do 8 and 9, and we'll do the last 2 tomorrow. Questions on number 7? All right, number 8. Now we're talking horizontal by a factor of 6. So horizontal stretches or shrinks. Let's see, what do I have to multiply? The input or the output? Let's see. Horizontal, look at, it's on your notes. I'm multiplying the input only by a value of a. Okay? So, if a is greater than 1, it'll be a shrink. It's kind of the opposite of vertical. If a is greater than 1, it'll be a shrink horizontally. Look at horizontally now. So if a is greater than 1, right here, mine is in blue. Yours is in, from last week, I gave you the handout. So if a is greater than 1, it's going to be a shrink. If a is a fraction, it'll be a horizontal stretch. And we're only multiplying the input now, not the whole output, by that factor. So coming back over here to number 7, or 8 rather. So I'm looking at the input only, which is x. So I'm just going to multiply that x by a factor of 6. So here we go. G of x equals 3 times 6x minus 9. Notice that. Because we want to multiply the input by 6. Yeah? That's going to stretch it. Okay? This is actually a typo. This is going to be a shrink. I'm going to put shrink here. Cross out stretch and put shrink here. This is a typo in the curriculum. I'm going to call the publisher. So this would be a shrink, actually, not a stretch. Gentlemen, I'm talking. Thank you. So I took the input and multiplied by 6. I got g of x then equaling 3 times 6 is 18x minus 9. Here's your new function. This would be a horizontal shrink. Okay? So this new function, g of x, if I were to graph it, it'd be closer to the y-axis. It'd be steeper and closer to the y-axis, hence we'll call it a vertical shrink. And this one's opposite. This one should be a horizontal stretch. They got it the other way around. Put stretch here. Another typo. I got to call the publisher. So, horizontal stretch. We're pulling the graph away from the y-axis. That's what a horizontal stretch is. I'm looking at the inputs only, x, and I'm going to multiply 1/4 by x only. So here we go. G of x then is going to equal to negative absolute value of 8 times, watch this, in front of x, I'm multiplying by 1/4. It's already 8 times x, and I'm going to put a 1/4 in there also. I'm multiplying that input by 1/4. And now we got the minus 4, actually outside the absolute value symbol. Minus 4. You can, if there's the input's in there, that input's there, so you have to multiply that input. And that's going to make this function shrink. Right, only when you distribute, exactly. So the distributed, exactly. Don't see multiplying 4 by the whole thing as a distributive process. It's not. It's 4 times that whole absolute value value. Whatever goes on in that absolute value, you're going to multiply it by 4 in the end. You can't see these as parentheses. But if we're going to do a transformation, we can take that input and multiply it by that factor. Because that's going to transform it and morph it into some new function. Let's keep going now. Let's simplify. G of x then is negative absolute value. 8 over 1 times 1/4. That's 2, huh? 2x minus 4. Here's your new function. This function would be a horizontal stretch of that function by a factor of 1/4. So this is a review of the difference between multiplying an input, that's just the x, versus a whole output, that's a different transformation. Okay? All right. Take a minute, look at your social media if you want.